Okay. So homework for, it was supposed to be the homework due on what, Thursday? Was the mimic what I did, but get it working for your basketball team player or something like that, right? Okay, so I don't need to go over that because we did it for we already had our patient record. The only thing that I noticed was kind of missed is when you were coming up with the various things for the basketball player, what types to use. So like the name should be a string type, age should be an int, right? And then it was height and inches, height in feet. So both of those should be ints.
Okay.
So int height in feet, int height in inches. Could you use a float? Sure, but typically if you're telling somebody you're 6'4", you don't say that you're 6.03 feet and 4.0002 inches. Right? It's a whole number on both sides. So 6'4", you need to store a 6, you need to store a 4. Those are both integers. Is there anything else we were supposed to?
Jersey number.
Jersey number, also an int, right? So string and 3 ints, 4 ints, whatever the types were. All right, does that make sense when you're going through and you are, where's my patient record? Oh, here. When you're going through and you're creating your own object, shut up! When you're going through and creating your own objects and you come up with your fields, your attributes here, you're going to choose types for those that are in line with the kind of value you're going to have to store. If I'm storing the first name, that's a string. The last name, that's a string. The middle initial, that's a char. You could maybe argue that you could store that as a string as well if you wanted to, just because Java really likes strings. All right, but char is probably the most appropriate type for it. And age should be an int. Make sense? All right, so you want to choose types that are related to the types of values you are storing. All right, so our code so far, let me just run this real quick. I think we have a button that takes us to the second page, right? And then that's like add dude thingy. And you add it, and then it creates that object and just spits it out to the screen. That's what it does right now, like puts it out just proving that we created the object and displayed it. So now we want to do something a little bit more with it today. And then on Thursday, we want to start putting that into a database, and we'll see how this stuff starts working. Big money. All right, so I'm going to say add patient record here, and we're going to go ahead. We'll just type some stuff in. Click add, and then if I go down here to logcat, it shows my output there, proving it made the object. And then here's my patient record, add new activity. When I hit the button, I grab my edit texts, I read in the information from those edit texts, I create an instance of my patient record in this case, and then I tell that patient record to display itself. Here's my, now here, a little quiz thing. So I'm creating a new instance of patient record here. I'm calling this method display using an instance of a class. Do you think display is a class method or an instance method? Instance method. How do you know? Because we're calling it, we're using it right now, right? So we're calling it with an instance. So when I go and look at that method, if I go and look at its definition, would I expect to see static or not see static? Not see static. So we come in here. Here's my display method. No static, which means that it is owned by instances of the class. Therefore, I call it using an instance of this class. Make sense? So that's seeing both sides of it. All right, so that's what display currently does, just testing that it worked. But realistically, what we'd like to do is we want to kind of get that information and display it on the screen somehow. Okay? Well, for starters, instead of me hitting add and having it spit that text out here, I want to hit add, have it added to some sort of collection of patient records, and go back to the first screen. Okay? So the first thing I'm going to do is I'm going to go ahead and get back to the first screen and then display all the patient records that are in that on that screen. Okay? So if I want to store something here, when I hit add, rather than I'm creating it locally and then I'm spitting it out, if I want to store that so it's accessible on the first screen, what are my options? What's the easiest way for me to create something on this screen and make it available to the first screen? Go ahead.
You could use an extra from the intent.
I could use an extra from the intent, but if I'm going to do that, I would have to have launched this thing a different way. I would have had to launch it, start activity for result. There's another version of starting an activity that we haven't looked at, where you're creating an activity, you're expecting a result back from it. The put extra thing that you're talking about is if I want to get information from screen 1 to screen 2. I could pack something in there inside of our intent. Our intent's kind of a suitcase. Now, if I'm going back to screen 1 from screen 2, I can still use the intent, but I would have had to launch screen 2 in a special way. I would start it and say, look, activity 2, I'm going to start you, but I'm expecting a result back from you. So there's a special callback method that would then get called where you could put an extra in there, and then when the first screen got that back, it can then go and unpack it and get that value back from it. Completely doable, not something that I'm going to say is super common. That's actually not fair. Not something I want to cover right now. Let's go that route. Okay, any other way that we have discussed that we can get information? Go ahead.
Like a static class.
Okay, so what we've called a singleton. All right, so we're going to go ahead and create a singleton. That's kind of like that global variable thing. All right, so I'm going to create a class that both of these screens can access. I'm going to draw a little picture for you first. What class is this? 300?
Yes.
All right, so I like drawing pictures. So right now we have our main activity, right? We have that dude. And then we have a second dude called, whatever it's, add patient record activity. All right, that's what that dude is. All right, now our main activity has a button that launches this guy. This guy has that form that we fill out some crap and hit the button, and then it creates a new instance of an object, right? I ultimately want that instance of an object to be available back here, okay? So what we're going to do is we're going to create, as he pointed out, a static class. It's actually not the class that's static. It's a class that contains a bunch of static things. We've called it a singleton, and I usually call that guy core. Just because, I don't know, I don't even know why. I think when I first did that, I had just finished watching that movie called The Core. You seen that movie?
Yeah.
It's actually like a better movie than it should be.
Yeah.
Oh, it's a great movie. Yeah, the magnetic field of the Earth has failed.
Yeah.
Okay, because the inner core of the Earth has stopped spinning. So they need to restart it. So they have this special ship that they're going to build that's made out of a material that just magically gets stronger the deeper you go. It's called unobtainium. It's completely awesome. Okay? So they need to drill deeper than they've ever drilled before, and they're flying it like a spaceship, and you got to like dodge diamonds, and it's completely legit.
Didn't they have like a laser drill or something?
Oh, they had everything.
Yeah.
Yeah, it was.
It was actually pretty good. I haven't seen it in a while.
I mean, this thing didn't win awards, but it's like a pretty decent way to spend like an hour and 45 minutes. You know, because all the other movies like Armageddon, it's like go up to space and blow something up, right? This one's go to the center of the Earth and blow something up. You know, to magically restart the core of the planet. Oh, and then of course their calculations were a little off. They had to destroy the nukes in like little sequences. real-time math. It was awesome. Totally a true story. But I'm pretty sure I just watched that movie. The name of the movie is The Core. So I'm guessing that's where that came from. I'm just speculating, but I wouldn't be shocked. Also watching a new show on Netflix right now called Pine Gap, where they've made Australia the bad guy. It's awesome. Australia never gets to be the bad guy. I mean, Australia's like Canada Junior, aren't they? All right. So, how do we get to Australia? Oh, it's the core. I don't even know how we got there, but watching shows. That's where we got there. Okay. So, in any case, I need some information that's on this screen to be available to this screen. And as he pointed out, one thing I can do is I can have this activity here launch this guy with the expectation of a result. But we're not going to look at that right now. So instead, what I'm going to do is when this guy finishes what he's supposed to do, he's going to write something to this class. Now, this guy's not an activity. This is just a normal, plain Jane class. Now, we've historically called this dude a Singleton, right? That's the kind of thing it is. And that's just a fancy name for global variable accessible to all objects. Thingy. Yeah, always put the thingy there in the end. All right, so let's just go ahead and we'll give a little definition for Singleton here just so it's in this semester's notes. Singleton. Remember, this is a design pattern. So it's a good idea to store information that needs to be accessed from, we'll just put it in the context of an Android application, from multiple screens. You could say multiple objects, whatever, from multiple screens in a single place. Hence, a singleton. All right? So, in practice, this is a class filled with public static fields and methods. For us right now, we're just going to put fields in there, but nothing keeps us from throwing static methods up there if we happen to have some functionality that needs to be shared among multiple screens. Maybe you have 3 different screens in your app that needs to be able to convert a decimal number to a binary number. Rather than write that function 3 times, you write it once, put it in your singleton, and then all 3 of those screens can access that same function. That make sense? So our singleton here is a little shared container, and anything we throw in there is accessible from the multiple screens. And if you remember from last semester, when we first talked about singletons, one thing I brought up is you'll see in a lot of textbooks that there's this, I'll kind of put it here. There's this saying where global variables are bad. All right, so in computer programming from a historical perspective, we always say that global variables are kind of bad. Now, I don't really agree with that, and the popularity of the singleton design pattern would also support not agreeing with that. The issue is that the abuse of global variables is bad. If you make every single one of your variables global just because you're lazy and don't want to have to learn about scoping rules, that's bad. Because then all of a sudden you have 5,000 variables that everybody has access to, even though only 4 of them need to be accessed by everybody. All the rest of them really should operate as little tiny local variables that live and die with the functions they were defined in. Make sense? All right, so global variables are not bad. Global variables should be targeted. Only make a variable global if it needs to be accessed by, I'm going to say, more than 2 screens in our context here. But you could make the argument that even if it's 2 screens, that might make more sense than duplicating a variable more than once. So that's where our singleton comes in. Just don't abuse a singleton, because it's really convenient to use. Therefore, you might say, well, I need these 2 different functions inside of a single screen to both have access to a variable, so I'm just going to go ahead and throw that in the singleton. That's not where it belongs. It belongs as a global variable within that screen, not within the entire application. All right, so if we look at this picture here, this singleton here, this guy we can say is global to the app. Anything we store in that core, everything in the app has access to that, which is great from a convenience perspective, but only put things in there that actually need to be accessed from everything in the app, or at least multiple screens in the app. Make some sense? All right. So that's the idea of our singleton. So we're going to go ahead and create this singleton. Then when we hit our button in here to create our new patient record, we'll create the instance of it, and then we'll store it in our singleton. Okay? Now, if I'm going to have a collection of patient records, I'm going to need some sort of data type for holding a collection of things, right? All right, so what kinds of structures do we know about at this point that could hold collections of, in this example, patient records? Arrays. Or if we're talking about Python, it is a list. It's a list in Python. You're a little bit dated, the knowledge, so it's your semester off. Okay, but good news is we're going to be learning about linked lists pretty soon. So you were almost right by accident. It's fine. Yeah, so, I mean, don't let that go to your head because it was really an incorrect answer. Did you miss me? See, you didn't get this kind of abuse during break, did you?
No.
Yeah, you had your friends and family all being nice to you and stuff like that.
You just remind me of Cinderella's stepmother.
Of Cinderella's evil stepmother? I'm going to take that as a compliment.
We need like a little sign for you, like says,
I do like that. That's a star for the day. Even though it's a very mean thing to say to somebody.
No, because here's the thing. I look here. I was laughing earlier too because you have like a pimple right here or whatever.
Oh. It's actually not. I performed surgery on myself.
I
Yeah.
was laughing the whole time because I was thinking of the stepmother.
Oh, does she have like some kind of face thing?
No, because in our tradition, there is a story of the stepmother, just like Cinderella too, but like Vietnamese tradition story.
Yeah.
And her style of looking just like you do with the pimple.
Yes, this was like some sort of skin tag or something. I didn't want it to be there anymore, so I cut it off. My wife yelled at me.
Oh my god.
It just bled forever too. It was terrible.
Put some salt on it.
Is that like is that a thing? It's like an old Vietnamese home remedy. Just what you want to do is you want to just make a major hole and just shove salt in there. And when you come to, when you finish blacking out, you'll be all better. All right, so we have our singleton, so we're going to go ahead and write this class first. Now this is just a plain Jane Java class. This has nothing to do with Android. This could exist in an Eclipse project, any old project, and it doesn't even have anything to do with Java. You know, you could write singletons in Python or any other language. Okay, so we're going to go ahead and create that guy. So I'll come in here, and we'll go to, this is in our app, go to Java, go to our folder where all our classes live. So for me, it's patient record example 2. All right, so you'll see main activity, patient record, add new activity. So that's where all of our .java files live. I'll right-click on this top level here. I'm going to create a new Java class. Now notice here that I think they do have a thing called Singleton, where you can create one, a built-in one. I don't like the way they do it. You can use that one if you want, but I like my way better. So, but at least you know that Singleton's a real word. Okay, so we're going to call this guy core. And I'm going to go ahead and just hit OK. And it's asking me, do I want to add it to my Git repository? I'm going to go ahead and click this button that says, remember, don't ask again. I'm going to say yes, because at the end of class, when I commit this code and then push it, I want this new file to also be up in GitHub, so you have access to it. So I'll say yes there, so it does the magic of doing that. Okay, so now Blaine told us that the collection type that we have available to us for holding collections of things is an array. So we're going to have an array in here capable of holding some patient records. Okay, remember that the syntax for an array If I want to have an array that can hold 10 integers, for example, I'm going to say I want an int array, maybe called AR, and this guy's going to be a new int array of size 10, right? So syntax for an array, or syntax for any variable, is type var name equals value. That's the generic syntax for any variable. This particular variable here has a type of integer array. The variable name is AR, and its value will be a new integer array of size 10. So what kind of value will this boil down to? Memory address. How do you know? New keyword. Yep. So anytime we see the new keyword, we know this is going to boil down to a memory address. Okay? Now in this case, we don't want to store a collection of ints. Instead, we want to store a collection of patient records. All right? So I'll replace int with patient record. And we're going to call this, instead of AR, we're going to call this guy the patients. And it's going to be a new array of patient records. And we'll go ahead and say it's of size 10 right now. All right? So we're going to talk about one of the weaknesses of arrays being that we have a fixed size for them. And probably sometime next week, we're going to look at a replacement for arrays. Not an upgrade, a replacement that is usable in certain circumstances, that is better in certain circumstances. An array will almost always be better if we know exactly how many elements we need to hold. In this case, we don't know how many patient records we're going to have, but we're going to kind of go with what we know right now. So I'm going to give myself a little storage container that can hold up to, here, we'll just make sure we can hold a lot of them. So we're going to say 1,000 patient records. For no good reason other than just, we have aspirations of having lots of patients. Okay, so we're going to have up to 1,000 patient records. But now I'm going to need to store one more piece of information. I need to store how many patients I currently have. Because when I go to add a patient, I want to add a patient the first time at bucket 0, then at bucket 1, then at bucket 2, then at bucket 3. So I'm going to have some counter that's going to tell me where I'm going to store my next patient inside of that array. All right, so we're going to have an integer called number of patients, and initially we have 0 patients. That make sense? Okay, so now we want these variables to be owned by the class and publicly available. So we're going to make all of them public static. We could actually get away without making them public here because all this is inside of the same package, so you'd already have access, but we're going to explicitly make them public. So I'm going to say this variable is public static. That means this guy is now a class variable, so we would access it using the name of the class, that is core.thepatients. Similarly, we'll make this guy public static. So he's a class variable, so we would access him using core.number of patients. That makes sense? So now when we create a new instance, and then we want to add it to this patient record, this is a collection of patient records, we can do that from our patient record add new activity. So this is where I created that new patient record. We proved that we created it here by printing it out, by displaying it. But rather than doing that, what we're going to do is we're going to add this patient record. We're going to add PR into core. So we're going to say core.thepatients. That's my collection of patients. At bucket, core.number of patients. So the first time through, it's going to be 0. So I'm going to add my new patient at bucket 0, and then I'm going to increment number of patients. This guy is going to equal that new patient record we just created. Make sense? Then we want to say core.number of patients plus plus. We'll increment that number of patients. That makes sense what we're doing there? Now, if we wanted to make this a little bit cleaner. We could write a function inside of core called add patient record and have that function do these 2 lines. Be a little cleaner. Okay? Because right now we're reliant on us knowing in here that my collection of patients is inside of a variable called the patients, and my number of patients is also a variable that's in there, when I could come into core and I can write a public static void add patient record, and this guy takes in a patient record as a parameter. And what he does is he says the patients, or if I'm going to spell this out, I'm going to say core dot the patients at bucket core dot number of patients is equal to PR, then core dot number of patients plus plus. So those same two lines of code. Now realistically, we could have actually omitted the core dot in here because we are in what's called a static context. So if we're inside of this function, we already are in a static context, so we have direct access to any of the static variables inside of this class. But it's never wrong to explicitly access those variables. In fact, you can make the argument this is probably quicker. That way you don't have to remember all these little tiny rules. Okay? So we're going to set these 2 things. And this is our add patient record. Now by doing that, what we can do is we can now make these guys private. Kind of lock them down. Remember our general rule is make variables as private as possible and only loosen the reins as we need to. So I'm going to make these guys private, which means they're only accessible inside of this class. I'll make this method public, which allows me to add a new patient record, and it will just do the magic of adding a new patient record, whatever that means. Make sense? So now I've sucked that logic, or I've encapsulated. So we would say we have encapsulated the logic of adding patient records here. So then out here in our add new activity, notice these 2 lines are no longer happy because I've made those 2 variables private. Now I'll say core dot add patient record, which is the name of a method. And the patient record I'm going to add is PR. That make sense? So what does that guy do? He comes up here to core. He finds this function, or this method, which takes a patient record as a parameter. We passed it, and it does the magic logic that is required to add a new patient record to our collection, and then ultimately increment the number of patient records that we have stored that allows us to add the next one. Make sense? Okay, so after we've done that, we are done with this second screen for this particular pass. So after I hit this add button, we want to do that creation, then that storage, then we want to go back to the previous screen. Okay, so we do that by saying this dot, what is it, finish? Yeah. So there's a function called this dot finish, and where this, what is the this keyword? Remind me. How an object refers to itself from within itself. And in this particular case, this is an instance of what? This is how an object refers to itself from within itself. In this case, this must be an instance of this object. It's a patient record add new activity, which happens to be an app compat activity. So if we want to talk about it generically, this is this particular activity, this screen that we're on. I'm telling this screen to go ahead and finish. And do whatever that means to finish. Clean up memory and all that other jazz. Okay, we didn't write that function. It's built into Android, built into the app compat activity in Android. So this will make this screen end and go back to the previous screen. Okay, so we'll go ahead and run that.
Do we need to write like this dot finish for our app?
Well, if you want the screen to go away, you do.
Is that
Yeah, I'll show you the difference. So right now, I go to that second screen. So I'm here. I go ahead and I put in the stuff. Now when I hit add, it's going to create that instance, it's going to store it in core, and then it's going to call finish on this screen, which makes this screen disappear, finish, and go back to the previous screen. So now I'm back on that previous screen. If I did not have this finish in here, it would do all the storage stuff, but it would just stay right there on that screen. Make sense? Okay. So now we've gone back to the whatever screen was next on the stack. We're going to actually talk about stack data structures in here as well. Don't worry about it right now. Just, we had our app running, and when we launched that second screen, it created the second activity, added it to the top of our stack of activities. And then when we told that guy to finish, it got destroyed, removed from the stack, and now the new top of the stack is our original screen. All right, that's just how the screens line up. Okay, so now we want that first screen to be notified when we come back to it. So we're going to look at Android Activity Lifecycle. I think this guy gives us some of those functions. We're already used to working with one of these guys. So if we go back to our activity here, the one that gets created for us is this onCreate. So when an activity is first created, its first portion of its life cycle, when it's first born, if you will, it calls this onCreate thing. But there's some other functions that will get called at different points in an activity's life cycle. So if we go through here, notice we have this onCreate, we have an onStart, an onResume, onPause, onStop, onDestroy. So let's click on onResume here. OnResume says when the activity enters the resume state, that means it comes to the foreground, the system will call onResume. All right, so let's prove this here. All right, now I'm telling you that every activity already has a function called onResume. So if I come in here and I do Android activity class, here's our activity, and notice that, well, it'll probably say somewhere down here, app compat activity is one of these dudes. That's probably a subclass of one of these. But if I come down here, well, this is talking about the life cycle anyways, but we have, here's activity, and we have all of these methods in here. One of them is called onResume. So an activity has an onResume method that does nothing. Okay? The life cycle of an activity is our opportunity to interject logic into our application as things are happening. So we might be interested in doing something special when that first screen resumes. Because one of the things that might have happened, in our case here, is when we left the first screen, that means we went to our second screen. And a new patient record might be in existence right now, right? It might not. They might have just hit the back button. They may not have actually created a new patient record. But a possibility is a new patient record was created. So when we come back, we want to check for that because maybe we want to update the screen. Show the new patient record or something like that. Okay? So let's look at how this can work. So I'm going to go to my main activity, this first screen here. And I'm going to go ahead, notice this guy says override before it. So this is overriding the default onCreate function that does nothing. Because when we were using Android Studio, it goes ahead and fills that onCreate function up for us with the idea of setting the content view of that activity to our XML design that we created. So it kind of does that for us. Remember when we first create an activity, it gives us the option to also create an XML layout for it. This goes ahead and automatically creates an onCreate that is compatible with that. But we want to go ahead and we want to write on resume. So just underneath here, I'm going to just start typing on resume. Notice it says on restart there. Go ahead.
Is it like the override? It's like something that you cannot delete, like the word is.
It's not that we can't delete it. It's that we are specifying to Android Studio for performance reasons that we are going to override a function that was previously given to us. So go ahead and pre-process that stuff. And I think it's actually from a scope lookup. So when we say on resume, it's going to look here rather than kind of try to look for it through the hierarchy of where that function may have come from. So I'm telling you activities have an on resume. Now in actuality here, the on resume that's in here is not. So that thing we were just looking at must be a little bit old. So we have an on restart, here's on resume, but that's a fragment activity. Let me actually look real quick here at app compat activity. So I'm giving you so we're using the correct. So here's app compat activity, which extends fragment activity. Okay, so on resume did come from that. If you look back here, when I started typing on resume, notice it comes from fragment activity. All right, so I'm going to go ahead and press enter on that guy, and it just goes ahead and writes the whole method header thing for me. And I'll just go ahead and do a system.out.println, and we'll put some asterisks in here so we can see it, and we'll say on resume. So we'll see when that pops up. Okay? So I'm going to go ahead and hit run. I'll clear out our logcat down here. So now the app is currently running. Now notice when it first launched, on resume got called. Okay, so as part of the original lifecycle, it was created, and then the very first time it showed up on the screen, it resumed. That make sense? So it was part of that life cycle. If we go back and look at our picture here, I think it was on this one.
Is there any way that you can like rephrase what does it mean by on resume? Because I don't really get this.
That screen came back. So if I leave the room and then I come back to the room, that's an on resume. Because you're going to see it work here in a second. You're going to see it work here in a second. Ask the question again if it doesn't make sense when you see it work. All right, so here is that life cycle. When an activity is first launched, this is the very first time, what gets called? On create gets called, then on start, then on resume, and now the activity is on the screen and running. Okay? These are the three things that happen the very first time an activity starts. All right, so now, when we click that button to go to our second activity, this activity is pausing. The first activity is pausing. So then we have some other points in time where we can interject. So a function called onPause will get called. Then onStop will get called. Now a user navigates to another activity, i.e. we launched our add patient record activity. That comes up here. All right. Now, that on patient record activity is another activity that's being launched. So it's going to go through all this stuff itself. But now as soon as we come back to our original activity, what's going to happen is going to call on restart, then on start, then on resume. So every single time the very first time we launch our activity, it's going to say on create, on start, on resume, now it's running. When we leave that activity to go to another screen, it's going to pause the current activity, it's going to stop the current activity. Then when we come back to this first screen, it'll call on restart for the current activity, then on start, then on resume. So we can put our code that we want to have happen inside of there, inside of on restart, on start, or on resume. Now, if we only want it to occur when we come back, we would put it inside of on restart. Because notice here that on resume happens every single time right before an activity starts running, including the very first time. But on restart only happens when we are returning to this activity from another activity. That make sense? Do you have a question?
So essentially on create, start, and resume are the same thing as awake and start from Unity?
Similar. Yeah, same kind of thing. Same kind of thing. So let's look at this as an example. So right now we have code in here on resume. I'm going to go ahead and write on restart as well. But before I do that, let's go ahead and let's see this work. So if I come back into here, we've already seen on resume show up here, right? And this is the very first launch of our app. We have not left this first screen yet. So now I'm going to leave this first screen. I'll go ahead and create my patient record. I didn't actually have to create it. I could have just hit back, but we'll go ahead through the motions here. I'll hit add. Now we're back to the first screen. Notice that on resume got called again. Make sense?
I have a question.
Go ahead.
What is the difference between on create, start, and on resume? I know that it's going through the process, but what is the difference between them, and why do they need to be in that order?
The order in which they get called. So if you look back at this chart here, the only time on create ever gets called is when an activity is first launched. That's the only time it ever gets called. So this is your opportunity, your one-time opportunity to ever interject logic when the activity is first born. On start happens the first time it's launched as well as when it's restarted. On resume happens when an activity is first launched, and it also happens when a user returns to this activity or when a user navigates to an activity. So notice on pause here, the user returns to the activity, so maybe that second activity shows up. The next thing that will get called is on resume. We want to look at on restart here. When does this guy get called? So an activity is running. When we navigate away from that activity, so this says another activity comes into the foreground. So this guy gets paused. Now, the activity is no longer visible. That's called on stop. We want to see when these guys get called. So when we go to that second screen, are we pausing and then returning? Or are we pausing, then stopping, then navigating back to it, restarting, on start, on resume? We're looking at the various the various time periods, the various functions that will get called, and the order in which they will get called as we are navigating through our application. All right, so we're going to go ahead and call on restart. In fact, if you just want to see all of these, let's go ahead. We already have an on create. Let's create an on start. We'll create an on pause. We'll create an on stop, and we'll create an on restart. We'll see all of these and see what we go through when we're navigating through our app. All right, so I'll come back in here. I already have on resume. We're going to go ahead and create on start and on pause. So there's my on start. Go ahead.
How do you know, like, your activities is pause or stop?
Well, we're going to see it.
Oh, I'm sorry.
I'm going to write this in here. So I just created I created on start, so I'm just going to take this system out here. And we're going to just type in on start for that guy. Then we're going to create an on pause and an on stop. So I'm just writing all these functions. So we'll see when they get called. So this is going to be an on pause. steal that line. We'll just type in on pause there. Then we have on stop. All right. And then we have on restart. All right, so these are all of the different functions that may get called when we do different things in our application, when we navigate away from an activity, stuff like that. Okay, and then ultimately come back to this activity. So let's see what all happens here when we go from screen 1 to screen 2. We can make a prediction here. Well, we already know when we first launch our activity, we go into onCreate, and if we want to actually be completely verbose here, we'll go ahead and write that println in onCreate as well. So we'll see that happen inside of onCreate. So what do we expect to happen? When our app first launches, we should see onCreate, onStart, onResume. That's what we should see happen right off the bat without us touching any buttons. That make sense? All right, because that's what this chart says should happen. So we're seeing if it's lying. So I'm going to go ahead and I'm just going to clear out logcat here so we have a nice fresh logcat. I'll go ahead and hit play. And I don't even need to navigate to that screen. I should see 3 things pop up here. On create, on start, on resume. Isn't that funny how I've always been looking at how to make that text bigger and I just decided to do the gesture thing and it totally worked? That's way easier to read, isn't it? Even for me, because my eyes suck with contacts in. All right, so on create, on start, on resume. I haven't touched the app yet, right? That app was just born. I haven't done anything else. Is that consistent with what we see right here? On create, on start, on resume? Yep, so far so good. So now when I hit my button to go to that next screen, we want to see what happens. Well, we expect on pause to happen. That when we leave this running activity, we're going to go to on pause. That should be the very next thing that happens. But now what we want to know is, does the activity actually stop? That is, the activity is no longer visible, which seems to be a true statement, right? The activity is not visible. Or does the activity just pause and then come back and get resumed? Under what circumstances does that happen? Okay, you're going to see this here in a second. All right, what do you expect is going to happen in this case? Is it true that our activity is no longer visible? Like when we go to that second screen where we're entering in name and age and all that stuff, can we still see the first screen? No, it's not visible anymore, right? We believe it exists, but it's not visible. So this text right here, the activity is no longer visible, seems to ring true. So what we expect to happen is we expect to see an on pause followed by an on stop. Now, our next activity is going to now go through its own little startup thing here, but we didn't write the functions in there, so we won't see any output. We're just visualizing what's happening with our original main activity. Okay? So the next 2 things we expect to see is on pause and on stop. So let's go here, and I'll go ahead and click my add patient record, which is going to navigate away from this activity, launching a new activity. Okay, what do we see down here? We see an on pause and an on stop. Make sense? Mm-hmm. All right, so we saw this, we saw this. So now this is the current state of our activity that was happening on that last screen. Now, why might we be interested in that? Well, maybe let's say on that first screen we had some sort of complex animation playing. It's taking up a bunch of system resources or something. If the human being can't currently see that screen, do we want that animation to be taking up system resources? No, so we can go ahead and pause that animation in there maybe. Does that make sense? That might be something we want to take advantage of when we get notified that that this guy finishes. We might want to go ahead and, or when this guy stops, we want to go ahead and pause our animation with the expectation that we'll just turn it back on at a later point in time. Maybe on restart, or on start, or on resume. Does that make sense? Because we're going to be given the opportunity to do that. Okay? Did you totally just fall asleep? I thought you were like super awake.
Yeah, it's starting to heavy now.
All right, so. All right, so we currently are on stop on main activity. Now look at the app here though, I'm on the second screen. Okay, so I'll go ahead and type some stuff in here. I didn't follow my directions. There we go. All right, now before I hit add, when we hit the add button here, what's going to happen? We're going to create an instance of patient record. We're going to call core's add patient record function, and then we're going to tell this activity to finish. Now, when this activity finishes, it's going to go through the process of pause, stop, and get destroyed, because we actually told it to finish. Okay? But that's on that second screen. We're not printing anything out from that second screen. We're only watching the things happen from our first screen. But I promise you, an on destroy would get called. So if you want to do some last minute, like, cleanup, maybe you had some files or something like that you had downloaded and you want to store them somewhere before everything just gets erased, you can do that inside of those. This is your last hurrah. Okay, this dude's being destroyed. If you have any last wishes, you do it inside of that function. Make sense? Okay, but this guy's going to get on paused, on stopped, on destroyed for that other dude. But now we're going to be navigated back to our first activity that is currently stopped. And what's going to happen? We expect to see on restart, then on start, then on resume. On restart, on start, on resume. See how that's working? At any point in time in here, these are all just different functions that are getting called in a certain order. So at any point in time, we can decide, I'm going to put some code in here, or I'm going to put some code in here, or I'm going to put some code in here. So on restart is kind of like our original on create. This is before we actually see it on the screen. So if you were to start an animation back up, maybe you want to have it happen then. Instead of once it's started and the thing's on the screen and there's like this little pause before the animation starts dancing around again, like the old Microsoft Word paperclip guy. If you had like a creepy pause, it came back to the screen, all of a sudden he just starts jumping and stuff like that. You want to come back and have him already jumping. Okay, so on restart will be before it's actually visible on the screen, but it's in the process of restarting. This guy, it's already on the screen. This guy, it's running. Go ahead.
Is there anything that you wouldn't want to have in these? Yeah, I can understand the on-start, on-resume, like that was what we had in Python. But
You mean within Unity?
Oh yeah, I'm tired. But on restart, is there anything there that you wouldn't want?
Things that are time consuming. So for instance, let's just say that you had some blocking code. Remember we talked about code last semester that might block? So if you have like a for loop that runs 1,000,000 times, okay, and maybe asks users for input or something like that, that's going to definitely pause the program, right? If you put that inside of on restart, you're not going to get back to the screen yet until it's run 1,000,000 times, asking the user 1,000,000 questions. Mm-hmm. So you want to think about the flow of your application. So things that need to happen, you want to put in there. A lot of these are going to be turning some feature on or turning some feature off or updating some widget that's going to be on that screen because we're about to see the screen again. Maybe we're going to have a list, for example, of our patient records. And before we actually visibly see that first screen again, we want that list to update. to show the newly added patient record. Does that make sense? That's where we're going with this. All right, so things like that are kind of quick. Computers are really fast. That's going to take some fraction of a fraction of a fraction of a second. No big deal. But you probably don't want to like calculate pi to the 4 millionth digit or something like that in there. That might take some time. Now, let's say that you had something in there that does need to be done, that does need to take some time, but might not necessarily be absolutely required to be finished before you come back to the screen. You just want to get the ball rolling. Okay, maybe you're grabbing some updated sports score or something like that off the internet, and you don't know how long it's going to take. It might be instantaneous. It might beat the screen actually showing up, but it might not. It might just kind of populate up in there in 3 seconds or something. Then you can put this thing in a separate thread. And we'll look at how to do some of those things when we start working with Firebase. You'll see this idea of asynchronous calls. But you can kind of get the ball rolling on something, but it won't block. It'll be running in its own thread. So don't worry about this blocking thing right now. We're going to talk about that quite a bit on Thursday into Tuesday.
So that's more like just putting an enumerator in instead of on the chart and that has its own.
Say this one more time.
Like starting enumerating a separate instance of it.
Yeah. If you're thinking, he's talking about Unity stuff. So yeah, that would be its own thread, its own separate thing. And we'll see examples of that through Firebase when we start doing database stuff. Right? He's referencing something he's done from a different tool. Go ahead.
Question, can you give me an example that like the activity stop right at on pause and go back to on resume? It's not go all the way to on stop, but just stop right on pause and go back to on resume. I just want to see how that works.
I get what you're saying. Okay, I think I can do it this way. Let's see if a toast won't do it. I don't want to spend time doing it right now, but I think a toast will do it. So let me just give ourselves another button here real quick. So I'm just going to throw another button in here, and we're going to have this guy say text pop up. All right, I'm going to go write a little code real quick for that dude. And let me minimize this here. So I'm going to write a function for that button. So this will be a public void on text pop up button press. This guy will take a view as a parameter, and then what I'm going to do is I'm going to have like this little pop-up on the screen that just says hello world or something like that. So we're going to say toast.makeText. The context is this. Here, what am I think the next thing is the message, right? Give me the full thing so I can see it. There we go. Context, character sequence. All right. So context is this. Hello world is the text. And then the length is, we'll do length long so we can actually feel it. And then we'll say show. So now when we hit that button, we're going to go ahead and have some text pop up on the screen just very temporarily. It maybe sits up there for like 2 seconds. Let me go ahead and hook up my button here. Go to the on click. There's my on text pop up button. So that's what this button will do. So when we hit that, we're going to have this. Did we do toast last semester? Okay. This is just going to have the screen's not going to go away. Okay, the main activity screen is going to still be there. But what's going to happen is you're going to have this thing kind of laying over the screen that's just going to say hello world or whatever text I typed in there for like 2 or 3 seconds, whatever toast long is, however long that pause is. And what I expect will happen, what I suspect will happen, is that main activity will pause and then it'll resume for that 2 seconds. It won't actually stop. Because it's not actually becoming invisible. It's just kind of going in the background slightly because this other thing is taking over the screen. Make sense? All right, so let's see this happen. money, big money. All right. So text pop-up, I'll hit that. There's hello world. Then it's going to disappear here in a second. That's the long thing. So let's see what actually occurred there in the background. Oh, we have to go down to the bottom. I'm going to just get rid of that for a second. I'll click it again just so we can see what ends up happening. Yeah, it didn't actually make it go into the background. So what would do it is something called a fragment. We can have a pop-up screen. So instead, like a screen kind of like this, but instead of actually going to a separate activity, we would have kind of that little form pop up over this screen. So the screen was still visible, but make text, the toast thing didn't seem to do enough to make that happen. It must do something with the current screen so that this current screen doesn't pause. But if you launch another activity, another fragment activity, let's see, I'll show you at least show you the code that it would have taken to do that. I just don't want to go into creating a whole fragment right now. If I say this dot, does it start activity from fragment, one of these guys, this will actually not put the current activity completely in the background. Instead, it would kind of have it sitting there, and I think it would then pause but not stop. But this other activity would start. Go ahead.
Would an alert dialog do it?
Possibly. We can try that real quick. Do you know off the top of your head the syntax for that?
I know it's alert.dialog and then alert.show.
Okay, alert. Here, alert dialog dot. Here, let's just look up a quick. See if there's a quick example of it here. Just steal the code. Yeah, I think it's gonna. Well, maybe we could do it from just these 3 lines. Give it the old college try. Let's see if that does it for us. I'm not going to go into how to do alert dialogues if this ends up working. I don't want to spend time on that right now, but if this shows us our example, that'll be good enough. So there's our hello world dialogue thing, and we actually don't have a button to make it go away, but it did not actually pause it. Yeah, so I'm thinking the only way it would do it is on a fragment. That's probably why it even exists, is you can have kind of like a pop-up screen for that's almost like a new activity, but it's not. It's a kind of an activity overlaid on kind of on top of the current one. Okay? So, from our perspective right now, this move right here would never happen. Not that it can't happen, but none of the things we know how to do right now would make that happen. I strongly suspect that's for fragments only. Fragments are not a super brand new thing, but did not exist in the early days of Android. It's probably been around for 6 years, 7 years, something like that. But a fragment's kind of like a mini activity that is shown within the context of the current activity. And I bet you that's when the current activity would pause but not stop. I think it would do this move here. But for us right now, we pause, then we stop, then we restart, then we start, then we resume. Make sense? Good enough for right now? We kind of see the life cycle that these guys are going through. So we have some opportunities to do some different things as we go through there. Okay. So I'm going to go ahead and get rid of that second button just to keep this as clean as possible. All right. So now what I'm going to do, I'm going to do this somewhat quickly so I can give you your homework assignment, is I'm going to go to Legacy here. I'm going to use something called a list view. All right. The new way of doing this is through something called a recycler view. That's here inside of, was it under common? Yeah, recycler view. It's a lot more complex to do that, and because we're not looking at performance and stuff, I'm going to show it to you in list view at some point. Maybe I'll show you the recycler view, but whatever. All right, so I'm going to grab this list view thing out here. We're just going to drag it in there. Okay. Now, just for the sake of time, I'm going to go grab some code here. I'm going to call this guy just list view. And I'll go ahead and in our main activity here on create, I'm going to create something called an array adapter. So first of all, let me go ahead and get that list view. So I'm going to say we're going to go ahead, we're going to have a private list view. Call this guy LV. We'll call it list view. All right, then down here we'll say this dot list view is equal to the list view version of this dot find view by ID r.id.list view. Nothing new there, right? Just giving ourselves access to one of our widgets on the screen. It happens to be a new kind of widget, but this is no different than a text view or an edit text. All right, now we're going to create something called an array adapter. So list views operate off of things called array adapters. All right, so I'm going to have an array adapter. Well, first of all, I'm going to give myself an array. So you're going to be manipulating a little bit what I'm doing right here to work with patient records. All right, so, and just for the sake of argument, let me do I have a open recent project? I think I did the sample here in this guy. Yeah, I did. So let me just steal this real quick just for the sake of time. This is not very difficult to do. All right, so I went ahead and I created a quick little string array called Bible books that has, Matthew, Mark, Luke, John, Acts, first 5 books of New Testament, right? Then I'm going to create an array adapter of strings that is built in terms of this string array of Bible books. Oh, I need to give myself that list view row. Isn't there a built-in thing? Let's look at my list view row here real quick. I think it's just a text view, right? Yeah, all it has is a label. Okay, good enough. All right, so I'm going to get rid of this click listener for right now. It's not necessary for what I'm going to do. I'm going to go to my resources. I'm going to go to my layouts. I'm going to right click on layout. I'm going to create a new one of these guys, and it's going to be a layout resource file. All right, and we're going to call this guy list view row. Okay, this is going to be a row in our list view. I'll hit OK on that because we're going to gut most of it. I'm going to go into design. I'm going to throw a text view in here just so I have it. Go back to text. I'm just going to steal my text view. I'm going to get rid of that constraint layout and just paste that text view back in there. Let's see, it wants height and width. What did I have height and width set for in this other one? I'm just going to steal this guy for right now since we are running low on time. So this is just the view that has a width and height and text size and things like that. So my entire view is just the text box. Okay? So we come back out here. Now this guy, so this is r.layout.listViewRow. So I'm going to create my array adapter. So I have a string array of Bible books. I have an array adapter. My array adapter is in this context. It's going to use that list view row. And then its source array is going to be my string array called Bible books. Then I'm going to go ahead and grab my list view from my interface. I'm going to set that list views adapter to my array adapter. So you're going to see now when I run this, it's going to show my Bible books, those first 5 Bible books inside of that list view. Okay? So I have a list view here. A list view gets an array adapter attached to it, and that array adapter is, there's 2 components to an array adapter. You have to have a text view, in our simple case here, for what's going to be in that, what's going to be on that screen, and then the array that's going to fill it. Okay? So for your homework, instead of having this show all of the Bible books, I wanted to show a string representation of your patient records. Notice that that should update when we come back to that screen. Make sense? Okay. Questions? I'll push this up to GitHub, so you'll have this as a starting point, so you can use this as an example. So now what you're going to do is you're going to have to use that on resume type stuff to tell our list view to update itself.
Let's do Thursday then.
Do Thursday, yep. Just real quick, I'll say Android, list view, refresh.
I can do that. It's really good.
You have like 2 coding class at the same day.
Yeah.
Just a change. So I'm going to just write in here, notify, is it?
See, important person
Invalid.
that I never seen. They supervisor?
Alright.
Data.
Have you ever talked to her?
A couple times, yeah.
Do you enjoy having a conversation with her?
Well, I had kind of a weird situation where there was a miscommunication that she didn't let me know, and I was kind of irritated.